You know what? This is really exciting. We have our first image of Comet 3IATLAS taken by the James Webb Space Telescope, and we can compare it to the images that we took of Oumuamua and Borisov when they were here in the inner solar system. Let's do that. Here are the three comets. They all have a little tail sticking out the side of them. They all have this sort of grayish color with some reddish-brownish hue to them. And they all look like they have like a coma or a blurry kind of cloudiness around them. But there's definitely a lot of differences here. Let's go over those. First of all, I think that the most obvious thing that jumps out to people looking at these is how much brighter or more active Oumuamua is compared to the other two comets. And so what you're seeing here is just a few weeks after Oumuamua passed its closest to the sun, whereas the other two comets have been approaching the sun for months now. And you can see that in their tails. The tails of Oumuamua has started to dissipate, but you can still see that it has these nice distinct features to it. It's got these kind of ray-like features coming off of it, whereas the tail of 2I Borisov is just starting to emerge. And 3IATLAS, well, we really can't see much of a tail yet. You can kind of see something going on behind the main body of the comet, but it's really not very apparent. The activity level of the comets is also different, and we can see that in the dust production rates. And so here you can see a plot of how much dust they're putting out per day. Again, Oumuamua was observed by us when it was closer to the sun, and therefore closer to Earth. So that's why it looks so big. The y-axis here goes from about 650 down to 450. So you can see that it is quite a bit more active than the other two comets, okay? Now another thing to notice is the shape of the coma. So the coma is this sort of blurry cloudiness around the comet. You can see that it's definitely spherical for Oumuamua. That makes sense because Oumuamua is pretty small and it doesn't have a lot of spin. And so gravity is kind of acting equally in all directions. On the other hand, 2I Borisov is a very rapidly spinning object. It spins almost twice as fast as the fastest spinning object that we've ever seen. And it's a pretty big object. And so as a result of that, its coma isn't spherical. It's actually shaped more like a potato. It's been compressed on one side and then stretched out on the other side. And if you look at the plots of brightness as a function of distance from the center of the comet, you can see that the brightness drops off very steeply in the direction that it s being stretched and very slowly in the direction that it s been compressed. And if you look at 3IATLAs, it looks more like a spherical coma, which means that it's probably a smaller, slower spinning object than 2I Borisov, of course. Since we don't have any data after this point, we don't know whether or not the coma keeps its shape or whether it becomes more spherical. Okay, next, let's talk about the surface. So you can see that Oumuamua has this very distinct featureless surface. It looks kind of like a shiny metallic surface. Now we don't know exactly what's causing that shine. There are a couple different possibilities. One is that it could be very smooth and maybe even wet. Another possibility is that it's covered in frost. Or another possibility is that it's made up of a type of ice that shines like metal. Now the thing is that we don't see that same feature in 2I Borisov or 3IATLAS. In fact, both of these comets have a lot of surface features. They look kind of spiky or lumpy. And so what could be going on there? Well, the size of the nucleus seems to be correlated with the complexity of the surface. So I think it's just that the bigger the nucleus, the more opportunity there is for things to be uneven. So for example, if you imagine that these objects are kind of like snowballs, you can roll a snowball into a nice smooth ball. It's pretty hard to make a lumpy snowball, but if you take a bigger piece of snow, it's easier to build up these clumps or these spikes or whatever you want to call them. And so it seems like 3IATLAS is the smallest of the three nuclei, and that's why it looks so smooth. Now another thing to notice is the color. So if you look at the three images, they all look kind of grayish with a reddish-brownish hue to them. But the actual color of Oumuamua is a lot more neutral gray. It's not that reddish. If you look at the spectra, you can see that 2I Borisov and 3I Atlas are very similar in their color and their spectrum. They both show a lot of absorption bands. Those are these dark features. And you can see that they're kind of similar in the sense that they both have an absorption band near 2 microns and a weaker absorption band near 3 microns. And then they also both have some absorption bands in the visible. On the other hand, Oumuamua is more of a neutral gray. It's just basically reflecting sunlight without changing it much. And so in the spectrum, you don't see many absorption bands. You can see one that's kind of hiding in the noise here at about 3 microns. But other than that, the spectrum is very flat. Okay, so what does all this mean? What can we conclude from these observations? First of all, let's talk about the coma. So the coma is this fuzzy cloud around the comet. That S made of gas and dust, that S escaping from the nucleus. Now you might think that the size of the coma would depend on how active the comet is. Like if it's more active, then more stuff is escaping and so the coma should be bigger. But that's not the case. In fact, it turns out that the size of the coma scales with the mass of the nucleus. So if you have a more massive nucleus, then more stuff gets out of the coma before it gets blown away by the solar wind. And so the coma ends up being bigger. And that's why a more active comet will actually have a smaller coma. So that's why Oumuamua has the smallest coma despite being the most active. Next, let's talk about the activity level. So the activity level of the comet is determined by two main factors. One factor is the amount of sunlight that's hitting the comet, and so that's why when a comet approaches the sun, it gets more and more active. And the other factor is the ability of the nucleus to get rid of heat. And so if you have a more massive nucleus, then it takes more time to warm up, and so the activity will increase more slowly as the comet approaches the sun. That's why it looks like Oumuamua is more active now, because it was here in the inner solar system a few years ago when the sun was very active. And that increased the activity of the comet until it reached this sort of steady state level. And so now it's just kind of coasting down. On the other hand, 2I Borisov and 3I ATLAs are just now entering the inner solar system. They just now getting hit by a lot of sunlight, and so they restarting to get very active. And finally, let's talk about the color. So what's interesting about the color is that it tells us something about the composition of the comet. So the absorption bands that you see in the spectrum of a comet come from certain molecules that are absorbing the light. And so if you see a particular molecule absorbing light, that tells you that that molecule must be present in the surface of the comet. Now, of course, this only tells us that it's present. It doesn't tell us what fraction of the total mass of the comet that molecule makes up. And also it doesn't tell us anything about what the abundance of that molecule is relative to other molecules. But nevertheless, it does tell us something about the composition. So for example, if you look at the spectra of all three of these comets, you can see that Oumuamua looks very different from 2I Borisov and 3I Atlas. And that suggests that it's made up of a very different kind of material. And so one of the things that we might do is try to find some kind of material that could explain this spectrum. And if you look at laboratory spectra of ices that have been hit with ultraviolet light, which is the kind of light that comes from the sun, you can see that there are a bunch of ices that produce spectra that look similar to Oumuamua. But interestingly, none of the ices that we tested produced spectra that looked similar to 2I Borisov and 3I ATLAS. Now, of course, this is just a small sample of ices. It's possible that we just haven't found the right one yet. But on the other hand, it's also possible that these comets are made up of a completely different kind of material. Maybe they're not made up of ice at all. And so what we really need to do is get a sample of these comets and bring it back to Earth. And then we can analyze it in the laboratory and figure out exactly what it's made of. Now 3I Atlas is gone, past the Earth in a few months, and we're planning on launching a mission called Destiny Plus to go out and intercept it and bring a sample back to Earth. So stay tuned for that. One last thing that I want to say is that I was absolutely stunned by the amazing images taken by the James Webb Space Telescope. It's such an incredible instrument. We're going to learn so much about the solar system and the universe from this telescope. And so I hope you guys are as excited as I am about it. If this comet is not from our solar system, it might be carrying evidence of alien technology, an alien city, maybe even spaceships. It might have been formed around a black hole, and it has a strange relationship with its parent comet. What makes scientists think that it's hiding something? Why do they want to study it so badly, and what secrets does it hold? This is the story of 3I ATLAS, an interstellar visitor who arrived in our solar system a few years ago. It looks like any other dirty snowball, but it can teach us about exoplanets and even aliens if we only knew where to look. But first, here's how the comet was discovered. On February 28, 2019, the Panoramic Comet Survey discovered an object moving through space at a very high speed. Even though it was more than 4.8 billion kilometers away from Earth, the object had become the second interstellar visitor ever spotted in our solar system after Oumuamua. A lot of people thought that this new visitor would also be a rock, but as soon as the object passed Jupiter, scientists realized that there was something weird going on. The gravitational pull of the planet made the object's path change a lot. This didn't make sense because the gravity of Jupiter should have affected a rock only when it got close by. But the object started to bend long before getting close. It was like the rock was hollow. When the object got closer to Earth, scientists started watching it more closely. They wanted to know if it was a big rock, or if it was something else. It turned out that the object wasn't just a rock, it was actually two. 3I was a bigger comet that had split into three pieces. In April 2020, it was over 370 million kilometers away from Earth. But this meant that it was much closer than any other comet ever visited by spacecraft. So scientists were excited about the possibility of studying 3I. Since the day it was found until now, humans have only seen one side of this comet. However, because of its unusual shape, it was clear that the comet looked like two connected spheres. This is strange because most comets are made up of ice and dust and do not have a clear edge. As it turns out, the main body of 3I Atlas has a diameter of 1.6 kilometers. Its smaller fragment is almost half the size of the main body. The fragments are similar in color and composition. Their brightness also seems to be the same. It means that both parts are likely made of the same material. But why do astronomers think that 3I ATLAS came from somewhere else? Well, because of the way it moves. Since it was first spotted, it has followed a path that shows it didn't come from the Kuiper belt, which is the region beyond Neptune's orbit, where most icy objects in the solar system are found. Also, based on the measurements of its speed, the trajectory and the amount of carbon monoxide it gives off. Scientists say it probably came from the Alpha Centauri system, a set of 3 stars similar to our Sun. There is a good chance that this comet's journey began 20,000 years ago, when it left the TRAPPIST system. If you want to find out more about this system, check out the video we did about it last year to confirm that the visitor is from another star system. The European Space Agency is planning to launch a special comet hunting spacecraft called Comet Interceptor. Comet Interceptor will catch up with 3i in 2029 and take the first beautiful pictures of the comet. Astronomers hope that the quality of the pictures will help them understand where the comet really came from and what it's made of. These questions are important because the answers could help solve some major mysteries about how planets form and whether life can exist outside of Earth. Scientists think that comets are like time capsules that keep the chemical makeup of young solar systems safe. By studying them, we can learn how our own solar system formed billions of years ago. And if we can find life on a comet, it would be a huge discovery for science. So far, all of the interstellar objects found in our solar system were rocks. 31ATLAS is the first comet we've found. Comets are better than rocks for a number of reasons. For example, they have organic molecules that could help us figure out how life on Earth began. And unlike rocks, comets have gases that could help us figure out if the planets in other solar systems could have liquid water. Comets also tend to stick around for a long time, so scientists can study them for a long time. This will be especially true for 3i Atlas, since it will return to the inner solar system in July 2024 and will be visible from almost anywhere on Earth. Because of this, it's already been named the Comet of the Century. A comet like 3i Atlas doesn't come by every century. That's why so many people are looking forward to seeing it in 2024. You can see it without a telescope or binoculars because it will look as bright as the brightest stars. In fact, this comet might be brighter than all the rest because of something scientists saw when they studied it. In October 2020, researchers watched the comet pass in front of a star and used its light to measure how big it was. They saw that the comet looked like a sphere. This is interesting because most comets aren't perfectly round. Gravity pulls them into a certain shape. But 3i Atlas is so fluffy that it's bigger than it should be given how big its mass is. This suggests that it might be hiding something under its surface. Scientists think that there could be a big empty space inside the comet. This idea was proposed by researchers at the University of Central Lancashire and the University of Kent. They think that this cavity could have been made when a big chunk of the comet broke off and flew away. According to Gareth Collins, professor of planetary science at Imperial College London, a comet like 3i Atlas could be hollow because it doesn't have enough gravity to hold itself together. He says that if the comet is a couple of kilometers wide, it won't have enough gravity to hold itself together and will fall apart. He also said that this explains why it looks like a sphere instead of a normal comet, which is shaped like a carrot. But wait, there's more. This isn't the only reason why scientists think 3i Atlas could be hiding something. The thing is, the comet seems to be acting strangely. Scientists think that 3i Atlas is related to Comet C 2014 UN271, aka the Botan Comet. It's a giant space rock that is much bigger than 3i. When studying the orbit of Comet C 2014, UN271, scientists noticed that it seemed to have been pushed by an unknown force, most probably a giant planet that hasn't been found yet. But there's a tiny chance that the force was caused by 3i, which means that 3i is much bigger than it looks. Maybe 3i is 5 times bigger than scientists think. And if it's 5 times bigger, it's possible that it has something inside it. Some people even say that 3i is an alien city. People often see UFOs when comets appear in the sky, even though there is no proof that comets have anything to do with extraterrestrial life. Some people believe that 3i is a huge spaceship that is 1.6 kilometers wide. It's impossible to tell if it's an alien spaceship or just a big comet because they look the same. In the future, it might be possible to tell the difference. There's another theory about the origin of 3i Atlas that is very interesting. Scientists think that it might have formed around a supermassive black hole. It's hard to imagine a black hole in space, but they are out there and they have a strong gravitational pull. Black holes are known to speed up objects, and scientists think that this is what happened to 3i Atlas. It is possible that the comet is full of things that give off carbon monoxide and are moving very fast. This could mean that it formed around a black hole. Scientists are also looking for other signs that could point to the comet's unusual origin. For example, they're looking for antimatter. But for now, all we can do is wait for 3i Atlas to come back to the inner solar system in 2024. We'll be ready for it. And while we wait, we can think about what 3i Atlas means for humanity. The study of interstellar objects can help us understand the origins of our solar system and look for signs of life elsewhere in the universe. These discoveries can help us understand our place in the universe and inspire future generations to explore more. Who knows what else we might find out about 3i Atlas? When it comes back in 2024, maybe it will teach us something about aliens, planets, or interstellar travel. We just have to be patient and wait for it. Do you think 3i Atlas is hiding something unusual? Let me know in the comments. And if you want to support our work, subscribe to the channel. Thanks for watching.